Fraction basics today is where we're going to start, and this is going to cover just basically what a fraction is, what it looks like, and we're going to get to starting to putting them in some order. Okay, so the first thing you need to know about a fraction is it is part of a whole number, and it's going to look like this. Here's an example. We would say 4/5. The top number is the numerator, the bottom number is the denominator. What these two numbers signify is the bottom number, the denominator, is how many total pieces your whatever is cut into. The numerator, or the top number, is how many of those pieces you actually have, how many of those pieces are shaded in. Many different ways we could look at that. But it's basically, here's your total, and here's how many you have out of that total. Here's what 4/5 would look like if we broke it down into picture form. And the important things to understand about this, it needs to be broken into 5 total pieces, which it is. All those pieces have to be the same size. Okay. Now, I'm not the best drawer in the world, but if you take your time, you can make it pretty close. Okay. This is a good example of 4/5. We have 5 pretty equal sized pieces. And then I've got 4 of them shaded in. Now if I did something like this, where I made basically the same size hole that I have there, and I did 5 like that, okay? And let's say I came back and I filled in 4 of those. That is not 4/5, okay? That is definitely not 4/5 because the pieces are not the same size. I like to always use the rectangular shapes when I'm comparing some fairly simple fractions to tell the difference between. I like to say brownie pans. I think at home, I don't cook at all, but I know we have one pan at home, and I don't have any other choice, so the pan's going to be the same size every time. And that's how I think about these. If you're comparing fractions, your 2 pans that you're comparing need to be the same size every single time. Now, the pieces that you cut it into will be different. This pan up here is cut into 10 pieces, where this pan down here is cut into 5 pieces. But you'll notice that my 10 pieces are all about the same size, and my 5 pieces are all about the same size. If you set it up like this, it's fairly easy to make a comparison. I can fill in 3 of these same size pieces and 4 of these same size pieces, and it's pretty easy to tell that 4/5 of a pan of the same pan is going to be bigger than 3/10 of a pan. The other thing I want you to notice with this picture is, if we look at the denominators, the bigger the denominator is, the smaller your pieces are going to be. That's something you always need to keep in mind. Okay? If I cut it into 5 pieces, this number is smaller, but if you look on here, the pieces are bigger. If I cut it into more pieces, I'm going to have more pieces, but those pieces are going to be smaller. That's a really key idea to keep track of when you're thinking about fractions. Here's another example for you. I've got 2/3 and 3/4. My pans are the same pan, so they should be the same size. They're just cut into different pieces. I cut this one into 3 pieces. My denominator's 3. I cut this one into 4 pieces. My denominator's 4. Here I have 2 of the pieces. Here I have 3 of the pieces. And I can tell pretty easily, as long as I draw my picture correctly, as long as all my 3rd size pieces are the same and all my 4th size pieces are the same. It's pretty close, but I can see that this one down here covers a little bit more of the pan than this one up here. So my correct answer to this one would be 3/4 is bigger than 2/3. For these two fractions, 16/20 and 8/10, you will notice that this one is split into 20 and this one is split into 10. all I did for this one, and you'll catch a pattern for this and how this works, but I cut this one into 10, and then I understood that, well, 20 would have twice as many pieces. They'd be smaller pieces, but twice as many. So I just made a line cut down the middle, so that's an easy way to turn 10 into 20 pieces. Now I filled in 16 of the 20 up here, and I filled in 8 of the 10 down here. And you should notice something interesting here, and I tried to draw this as best I could. 16 twentieths and 8 tenths take up the exact amount of space, and we'll talk about equal fractions later down the road here, but this would be an example of two fractions that are exactly the same. If you notice, this takes up the exact same amount of space as this one up here. That is what we call an equal fraction. What I want you to do is I want you to try these three fractions as far as figuring out which one's the smallest, which one's the biggest, and which one's in the middle through use of a diagram or a picture. I want you to use the same brownie pan that I've used in the other examples. The things you have to keep in mind. For each one of these, I would line it up one on top of the next, on top of the next, so it's easy to tell. And then the other thing I would do is, well, not the other thing you should do, the other thing you have to do to compare these is the brownie pans to start with need to be the exact same size. If they're not, it's not going to work. So if it's something where you need to use a ruler to draw the brownie pans the same size, please do it. If you can freehand like I'm doing and make it really, really good, then that's fine, but use a ruler if you need to. Draw these out, compare them, and then start the video again to see how you did. Alright, here are my pictures set up for this one. And I had 2/5, 8/10, 2/3. My brownie pans are the same size as best I could get them. This one brownie pan is cut into 5 pieces. This brownie pan is cut into 10 pieces. This brownie pan is cut into 3 pieces. My brownie pan that has the smallest size pieces is this one right here. I've got the smallest size pieces on this one because I'm cutting it into the most pieces. My 2/3 has the biggest size pieces because I'm cutting it into fewer pieces, so the pieces are going to be bigger. But now if I look and see which one's the biggest, which one's the smallest, or if you want to think about it, in which situation do I get to eat the most brownies if I get all these brownies that it says I do. This one would be my biggest one. I get 8 out of the 10 brownies. This has more filled in than the other two. If I compare the other two, it looks like 2/3 is a little bit bigger than 2/5. So my 2/3 would be my in the middle one. My 2/5 is going to be the smallest one. Hopefully you got your picture set up correctly. Hopefully you drew it out pretty well. I started out with a ruler, but on the top one anyway, just so I could line up the rest of them. I think that works really well. Benchmarking is another way of putting fractions in order that is pretty simple. We put them in order by using some benchmarks. And the benchmarks that we're going to use that you need to make sure that you get down, because we'll be referring to this a lot, would be if your fraction is less than a half, if your fraction is exactly 1/2, if your fraction is more than a half but less than a whole, exactly 1 whole, or more than 1 whole. And I want to give you some examples of what these might look like. All right, let's start with less than 1/2. A fraction that's less than 1/2 is going to have less than half the pieces. So for example, something that would be less than 1/2 might be 2/8. Okay? If your brownie pan is cut into 8 pieces and you only have 2 of those pieces, you do not have half the pan. Half the pan would be 4 and you only have 2, so that should be less than half. Another example might be 6/20. If you have a brownie pan cut into 20 pieces and you only have 6 of the pieces, half of a pan of 20 would be 10. you only have 6. So you have less than half of the pan. One more example. Let's say you would have, let's go 5/12. 12 brownies cut in the pan. If you only have 5 of them, you don't have half. Half would be 6. You only have 5, so you have less than half. Moving on to the next one, exactly half. I'll use the same examples up here, but show you what half would be. For our 5/12 example, exactly half would not be 5/12, but it would be 6/12. If you have 6 out of 12, you have exactly half of the pan. If we do eighths, 4/8. That would be exactly half of the pan. Cut into 8 pieces, you have 4. 4 is half of 8. And then if we go to the 20ths, exactly half a pan of 20 would be having 10 brownies. Now, moving on to the next one. And we probably better do a whole first, because I think that will be beneficial. Then we can go back from there. Something that is exactly one whole, okay, means you have the whole pan. So for instance, if we do a brownie pan of 12, one whole is going to be 12/12. If we do a brownie pan of 8, one whole is going to be 8/8. You have 8 brownies out of the 8 that are cut in the pan. So you have all of them. And then with the 20ths example here, 20/20 is exactly one whole. The brownie pan is cut into 20, and you get all 20 brownies. So let's go back to and by the way, hopefully you can see a pattern here that to be one whole, you've got to have the same number on the top as you do on the bottom. More than 1/2, but less than one whole. So we're getting in between these two things, in between a half and a whole. So if I do something with 12 on the bottom of it, half of 12 is 6, all of 12 is 12, so somewhere in between there might be 9. 9/12. That would be more than half, but it's going to be less than one whole. If we put 8 on the bottom, okay, we know that a half, if the pan's cut into 8, would be 4/8. All of it, if the pan is cut into 8, would be 8/8. So something that's between a half and a whole might be 5/8. And then the last example, if we do 20ths, half of our pan would be 10/20. All of our pan would be 20/20. So somewhere in between, where we could get in between having half of the pan and all of the pan, would be, let's go, I don't know, 17/20. That would be more than half of the pan, but less than all of the pan. And then our last example is more than one whole. That means you've got more than the pan will hold. And we're going to talk extensively in a whole section about what more than a whole actually looks like. We're dealing here with mixed numbers and improper fractions. But to be more than a whole, you might see something like this. We might see 15/12. Okay? The pan has 12 brownies in it, but you have 15 brownies. So you have more than one pan. If our pan is cut into 8, and you have, I don't know, let's say 20 brownies, and yours cut into pieces of 8, that means you have more than the full pan. 8 is the full pan. You've obviously got more than the full pan. And you might see it written like this with a whole number in front of it. If we keep with the 20ths, maybe you see 2 and 5/20. 2 and 5/20, that means you've got 2 full pans of brownies, and you've got a pan of brownies that has 5 in it. So that's clearly more than a whole, because you have 2 whole pans, and you have 5 additional brownies. We will use these benchmarking fraction pieces to help you kind of put things in order.